Here's a question which involves Kruskal's algorithm. We have to draw a weighted network. We've got to find a minimum spanning tree, and we've got to draw the tree. So here's the same question. I've just reduced it in size so I can fit it all on the screen. So we've got 6 vertices, and the answer book provided puts them in this configuration. So let's start by going down the first column. We know from A to B is 24, so let's do that. We know from A to E is 23, and A to F is 22. So that's taken care of the first column and also the first row. So now let's work down the second column. We've already done A to B. We've got to so we've got to do B to C, B to D, B to E, B to F. So that's the first 3 of those done. Going from B to F, we know is 20. Personally, I don't like drawing a line like that because it crosses. It will cross at this point here, and that's another vertex. So personally, I just like to draw that around the outside like that, and we know that's 20. Now the mark scheme doesn't seem to mind if you do it crossing to form another vertex. I just don't like that. Anyway, that's the second row and the second column done. Now let's do the third row. And now the fourth row. We've done BD and CD, we haven't done DE yet. And finally we've got EF to do, which is 21. So that's the weighted network. Okay, now we're going to use Kruskal's algorithm to find a minimum spanning tree. And the first part of Kruskal's algorithm is to sort all the arcs into ascending order of weight. So let's do that. The smallest arc is CD, which is 11. The next smallest arc is DE, which is 13. The next one is CE, which is 14. So let's carry on with that. So there we have them. Now let's just check. Easy to miss one out. How many have we written down here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's right, 11, 22. Each arc is in here twice. 2 11s are 22. So, that's the first thing. Sort all the arcs into ascending order of weight. Then number 2 is to select the arc of least weight to start the tree. So that's CD, which is 11. So let's write down CD, which is 11. Then the next thing is to consider the next arc of least weight. Does it form a cycle with the arcs already selected? No, it doesn't. I'll explain what a cycle is in a minute. It's DE, which is 13. So let's draw DE, which is 13. What's the, and I need to write here, accept. Now CE 14, if I were to draw CE, I would draw the line in here. Now this would form a cycle. Now a cycle is a closed path. The end vertex of the last edge is the start vertex of the first edge. So if I draw that in here, I can go round like this. I can start at C. The end vertex of the last edge, which would be C, is the start vertex of the first edge. So I don't want to form a cycle. Sometimes it's called a circuit. So for CE, I'm going to reject that. So now what about BE? BE does not form a cycle, so let's draw BE and put in 17. So that's okay. If I draw BC, it's there. It forms a circuit. It's like a closed path. So BC I'm going to reject. BD I'm also going to reject because that would also form a cycle or a circuit. What about BF? No, we haven't used F yet. So BF, let's draw that here using the same configuration that's on the answer sheet. So that's 20, that's BF. EF is 21. If I draw in EF, it's there. That would form a circuit or a cycle. So I'm going to reject that. Then I've got AF 22, so I can draw that in. That's okay. AE would form a circuit, AB would form a circuit. So this is a minimum spanning tree. Now a tree is a connected graph with no cycles. It's connected because all the graphs, or all the vertices are connected to each other. So I've got A, B, C, D, E, F, they're all connected in some way. And there's no cycles, there's no circuits. That's what a tree is. Now a spanning tree is a subgraph which includes all the vertices of G and is also a tree, and will include all the vertices. So this is the question completed. As always, we need to make sure I've read the question, and there's one thing I haven't done yet. Yes, I've done that. Yes, I've done that. Yes, I've done that. Oh no, I haven't done that. The total weight. Just add up the numbers. So easy in D1 just to miss out little bits and pieces. Read the question, find its total weight. Let's draw that in here. If I add those numbers up, it makes 83. So the total weight of the graph is 83. And what are the units? It's all in meters. It says it's in meters there. So it's 83 meters.